welding expert, uh, and he has a huge years experience on this welding. So just we are waiting for a few persons who are going to join. Maybe within 5 minutes we will start. So request you to please hold on till that time. Thank you.
Hmm. Good afternoon to all our dear customers and colleagues from our channel partners as well as Tata Steel. As you know, we have launched an initiative eCafe, which is a digital marketing initiative last year. Under this program, we have taken initiatives for various things. One of the key things is that webinar, how we can help our customers in improving their manufacturing process. And today, this second webinar, which is primarily on welding, best practices on welding. So to give this talk, we have got very welding expert, Mr. Apurba Kumar Sanyal, who has got 40 years of experience both in the shop floor as a production specialist on welding, as well as quality assurance and quality inspection in various organizations, from normal fabrication to shipbuilding and even nuclear welding. So he will talk of welding. So all the best for a good sessions, and I think it is an interactive session. So any query and all this thing after his presentation you should ask and clarify. And ultimately the objective of our this e-cafe is how to help to improve your process of manufacturing. Welding is a very key parameter. That's why we have taken a topic. Well, in the coming months, we will be taking various topics which will help our customers to improve and adapt best practices, which will help them in improving their yield and reduce their production cost. Best of luck, and the mic is over to Mr. Apurba Kumar Sanyal.
Thank you, Mr. Sanjay. Welcome, good afternoon, and welcome to all the attendees and viewers to this welding show. Thanks and congratulations to the organizer, Tata Steel and Versus Communication, for giving me the opportunity to speak in this show. Welding. In today's world, welding is a part of the life. Wherever you go, in any industry, small, medium, or heavy, welding is a must. Welding skill and knowledge is in high demand in all over the world. It is a skill that needs to be refreshed regularly to be competitive. I'll stick in the following points today, and these are manual metal arc welding, good quality welding, welding for galvanized steel, welding for galvanized steel, gas metal arc welding parameter setting, and mode of metal transfer. Welding. Welding can be classified into the following: fusion welding process and non-fusion welding process. What is welding? What is the definition of welding? Welding is a process of joining of two pieces of material by heat and temperature, with or without the application of pressure, with or without the application of filler metal. So welding can be classified into the two: fusion welding and non-fusion welding. Fusion welding process: manual metal arc welding, gas metal arc welding, flux core arc welding, gas transfer arc welding, submerged arc welding, oxyacetylene welding. etc. Non-fusion welding, brazing, soldering, explosive bonding, etc. Manual metal arc welding. It is also known as shielded metal arc welding, SMAW. Welding skill. Welding skill depends on four essentials of arc welding. These are correct electrode, correct arc length, correct current and voltage, correct travel speed. Correct electrode. The choice of an electrode depends on the diameter of the electrode, mechanical properties of the base metal, welding position, joint type, and current value.
Why don't you tell them to ask questions? They can type the questions. Just take the bulletin.
Okay. If you have any question regarding welding, please type and send it to us. Correct electrode, correct arc length. Correct arc length is very important for good quality welding. Hence, uniform arc length requires great amount of skill. See the correct arc length, short arc, long arc. The arc length should be ideal. It should be in correct arc length. Then short arc length reduces the voltage, therefore reduces the heat input. Reduces the results, short arc length results slag inclusion and lesser strength of weld joint. Long arc length increases the voltage, therefore results unstable arc, a flat weld bead with spatter and undercut. The weld joint, if your arc length is correct, the weld joint will have consistent profile and minimal spatter in the correct arc length. Good bead appearance, excellent weld quality. Ideal arc length is 2 to 3 millimeter. And results of arc length, see, long arc length in the left side, short arc length in the right side, and in the middle is correct arc length, shown the good quality weldment by MMW process. Correct current and voltage. These electrical parameters are of great importance in order to get good quality weldment. These electrical parameters are great importance in order to get good quality weldment, and the thumb rule for correct current setting is diameter of the electrode into 40 plus minus 20.
There is a question. You may want to answer. The question is which, sir, yeah, this is the question, which?
Yes, TIG welding is giving more strength.
That is a question.
More strength in comparison to MIG. Actually, both are same, but better quality welding can be available by TIG process. Or any question? So, current setting, thumb rule of current setting is diameter of electrode into 40 plus minus 20. Current setting in MMW, only current has to be set due to the power source. Voltage will automatically set by the machine. A minimum voltage is required, that is OCV, open circuit voltage, to start the machine along with the initiating the arc. This is due to the CC type power source in MMW. Low current.
There's another question by Mr. B.N. Gupta. So you can address it to him. This is the question. You can say it's a question by Mr. B.N. Gupta. Please check it.
No, arc length, ideal arc length is 2 to 3 millimeter in any process.
Bolun, question teaching.
Just repeat the question. Just tell them there is a question.
Yeah, there is the question is arc length varies with the thickness of the substrate or mechanical properties? Yes, with regard to mechanical properties, it varies if arc length varies. The ideal arc length is 2 to 3 millimeter. If you go to the TIG, MIG or MMW, whatever the process. So low current setting, too low current setting results in narrow bead and the arc will tend to towards one side of the weld. Results is lack of penetration and lack of fusion. LOP and the LOF. High current setting the current too high will result in a wide and flat and irregular bead with possible undercuts. A crater will also form at the end of the joint if you set the current in high mode. And slag will be difficult to remove at the edges of the weld. See the pictorial view of high current setting by MMW with maximum spatters, undercut, everything. Result of correct current setting, the bead will be consistent, smooth ripples, round in shape, the slag will come out easily. See the picture of the 2G butt joint. 2G butt joint. See, unique welding in 2G process. Is there any question? Okay. Okay. Correct travel speed. The bead is fairly consistent. The ripples are semicircular where the travel speed is correct. See the pictorial view of correct travel speed, unique welding bead. Excessive travel speed results in a thin weak bead. The ripples are elongated and triangular. Uneven bead will occur. Travel speed too low produces inconsistent bead. Excessive bead height and reinforcement, a high heat input, which will affect the welding properties. So criteria for good quality welding: good penetration and good fusion. Good penetration and good fusion. Defect-free welding. Match the weld metal properties with the base metal. For the criteria of good quality welding, see what should be the penetration for a good quality joint. See the pictorial view at the underside of the weld is a good and unique penetration on the reverse side. This is a butt joint. See the root penetration, reinforcement, toe, fusion zone. So unique butt joint. This is called a unique butt joint. This is a unique fillet joint. Major welding defects which I have quoted in my good quality welding, good fusion and penetration. Major welding defects, defect-free welding. So major welding defects are crack, lack of fusion, lack of penetration, undercut, slag inclusion and porosity. These are the major welding defects of welding. Matching the weld metal properties with the base metal, as I have intimated to you. The quality of a weld joint depends on the matching strength of weld metal in terms of ultimate tensile strength. This is also indicated in many international codes like ASME Section 9, ISO 9606, EN 287 Part 1, API 1104, wherever you go. Unmatched weld metal is also reason of failure, the bending properties. Passing the bend test indicates the soundness of the weld. This is an example of AWS classification of electrode. It is mentioned in every electrode, every quality electrode. Like first, for example, E, then dash 4-digit number, like 6013, 7018, 6011, 6010, like that. So E stands for, E designates as electrode suitable for manual metal arc welding. Then first 2 digits give minimum tensile strength of deposited weld metal into 1000 psi. Then third digit indicates welding position, and last one out of 4-digit number, 4th digit stands for current condition and type of covering or coating. Check the example. AWS classification of electrode E7018. E designates as electrode. 70, then first 2 digit 70, ultimate tensile strength of 70,000 psi. Then third digit 1, 1 indicates that the electrode can be used in all positions, that is flat, horizontal, vertical and overhead position. And the last digit 8, 8 stands for low hydrogen powder. The coating contains low hydrogen iron powder and the electrode should be used in DC reverse polarity and AC also. See the last digit. What is the meaning? If the last digit is 0, high cellulose sodium and can be used in DCRP, DC reverse polarity. If last digit is 1, high cellulose potassium and should be used in DCRP. If 2, high titanium sodium, it can be used in AC and DCRP also. If the last digit is 3, high titanium potassium is the coating, and this electrode can be used in AC, DCSP and DCRP also. If the last digit is 4, iron powder titanium, it can be used in AC, DCRP and DCSP also. If the last digit is 5, this is low hydrogen electrode, low hydrogen potassium and can be used in AC and DCRP. If the last digit is 8, this is also a low hydrogen iron powder electrode and can be used in AC and DCRP also. Is there any question? What is 2G? 2G is a bar joint used to weld in horizontal position. Any question on that? The current setting changes with change in metal thickness? Yes, it is. Current setting depends on the thickness of the material to weld by any process, MMW, TIG, MIG, whatever the process is. So current setting depends on the thickness of the material. Yes, leak-proof welding can be checked by the easier process is dye penetrant test. Very easier process. Anybody can do that. Leak-proof welding is done by NDT called DPT, dye penetrant testing. And also MPT can be used, but easier process is DPT. Is there any method to reduce the MIG weld bead or it is operator skill? Yes, this is also with regard to the welding process and operator skill. You have to upgrade the skill of the operator also.
So, no question.
Is there any question?
There is.
What is the reason of
No, this one.
short filling? No. Do current setting changes with the change in metal thickness? Yes, it is. It depends on the thickness of the material.
Point.
Okay. Major welding defects, its causes and prevention. Major welding defects are crack, lack of fusion, lack of penetration, undercut, slag inclusion, and porosity. So crack may be of three types: hot crack or center line crack or solidification crack. Number two, hydrogen-induced crack, delayed crack or cold crack. Number three is crater crack. Causes of hot crack: depth with ratio either too small or too large, high sulfur or carbon content, large root gaps, high heat input. The causes. These are the pictorial view of hot cracks. You see the transverse cracks, toe cracks, underbead cracks, root cracks, and longitudinal cracks or solidification crack. And prevention of hot crack: depth width ratio of a bar joint should be 1:1.4. Reduce sulfur or carbon content. Control feet up to reduce the gap. Reduce arc energy. If you do that, hot crack will be prevented. Causes of cold crack: high carbon or alloy content, insufficient heat, high joint restraint, hydrogen pickup during welding. Check the cold crack, pictorial view of a cold crack. Prevention of cold crack: reduce the carbon or alloy content, use preheat, reduce joint restraining, particularly in thicker material, redrying the electrodes. Let's check the question. Okay, the CC type, number one. Yes, the CC type power source stands for manual metal arc welding and TIG welding. CC type, constant current type power source. These are involved in TIG and manual metal arc welding. Next. Yes, we will be coming for the welding for the galvanized steel at the last, at the end. We'll show you. Why these are cracks observed in MIG welding. So we'll be coming for MIG process also. Causes of crater crack. Causes of crater crack: it forms at the end of the weld run. It forms due to the correct welding technique. Incorrect welding technique, it occurs due to the lack of skill of the welder. See the pictorial view of crater cracks, which is occurred at the end of the weld. This is for insufficient weld filling. Prevention of crater crack: to properly weld, the crater should be filled before breaking the arc. This is done by reversing the arc travel direction before breaking the arc. Deposit more weld metal before withdrawal of the arc. The strength of the weld joint under any conditions of loading be very seriously reduced the strength of the weld by presence of this type of cracks in a weld. Under no circumstances should the fault be permitted. There is another question. Okay. Yes. How to select electrode dia in MIG welding? This depends on the welding position to be weld. Like if you have 3G welding, you should go for a lower dia filler wear, but the versatile filler wear dia is 1.2. You can go by this 1.2 filler wear in any position: flat, horizontal, vertical, and overhead. But for specific reason, if you go for a specific 3G welding or 3F welding, AFIL should use 0.8. How to find out solution while welding galvanized steel? We'll be coming to the galvanized steel chapter at the end of this show. Thank you. Yes. So what can we do for the prevention of smoke release during welding? You can depute, you can employ a fumes extractor or blower to before question should be given to release the smoke or fumes from welding. Use fumes extractor or blower. So next type of lack of fusion. Lack of fusion may be of three types: lack of root fusion, lack of sidewall fusion, lack of inter-arm fusion. See the pictorial view of lack of root fusion. Here lack of root fusion, and the other portion is lack of root penetration. Causes of lack of fusion: low current, high welding speed, improper welding technique, flooding of weld metal ahead of arc in a tilting joint, lack of proper cleaning of the weld face. See the pictorial view of lack of inter-arm fusion. In the above, sidewall, lack of sidewall fusion. Next, lack of inter-arm fusion also. Prevention of lack of fusion: use adequate welding current in your joint. Reduce welding speed. Maintain proper electrode angle. Keep the joint surface in such a manner that should not be tilted in one side. Deslag in each weld pass thoroughly. This is very important. Place each weld pass correctly next to each other. Causes of lack of penetration. So first is crack, then lack of fusion, then lack of penetration chronologically. Lack of penetration causes the welding speed is too fast, improper joint preparation, insufficient welding current, the electrode used in the root run is too large, long root face and insufficient root gap are the causes of lack of penetration, LOP. Check the pictorial view of lack of penetration. The upper side is lack of penetration, in the lower side is good penetration. Prevention of lack of penetration. Do not weld too rapidly. If the speed of travel is too fast, insufficient weld metal is deposited. Use correct joint preparation. Use proper welding current. Select the electrode die according to the root gap. Like if your root gap is 2.5, then you should use 2.5 die electrode. If your root gap in the butt joint is 3 mm, you should go for the 3.15 mm die electrode. Control fit up and root gap should be 2.5 to 3 mm. Ideal root face is also called root land, should be 1.6 mm, but it can go up to 2 mm also. Sharp edge preparation should not be given to the welder, then burn through or melt through will be offered. Causes of undercut. These four: crack, lack of fusion, lack of penetration, undercut are called linear defects. Linear defects are dangerous for welding, not permitted in welding. So causes of undercut: excessive arc length, high current, high speed of travel, use of damp electrodes, presence of heavy mill scale on the surface, rusty surface, arc directed to the vertical members of the joint in case of fillet weld. Check the pictorial view. On the vertical member, there is an undercut. Prevention of undercut. Keep arc length within 2 to 3 mm. Reduce current. Check welding speed. Use baked electrodes. Dress the weld surface before starting the weld. Electrode angle should be 45 degree during fillet weld. So these four, crack, lack of fusion, lack of penetration and undercut, are the linear welding defects, should not be permitted in welding. Next, causes of slag inclusion. Inadequate cleaning of each run in multi-run technique. Excessive current, long arc length, incorrect joint preparation, improper welding technique are the causes of slag inclusion. Actually, welder is solely responsible for slag inclusion, nobody else. This is a picture of slag inclusion. Prevention of slag inclusion, deslag each run before the next pass is starting. Use of proper cleaning technique, use of proper current, use of uniform and steady arc length for the prevention of slag inclusion. Causes of porosity, use of wrong electrode, long arc length, improper welding technique. Major causes of porosity is poor base metal. Improper cleaning of weld joints before starting of welding may lead to porosity. Dirt, paint, moisture, etc. should be cleaned, properly cleaned. Improper welding procedure results in porosity of weld metal. Use of damp electrodes lead to porosity. Excessive moisture in the electrodes, and check the pictorial view of porosity in the lower side picture, in the above side picture. This is a MIG process. This is also MMW process. And prevention of porosity, use of proper electrode, maintain uniform arc length. As I said, the ideal arc length should be 2 to 3 millimeter. Correct the welding procedure, maintain the proper cleaning of dust, paint, oily substance before the next run is started. Never use damp electrodes. Re-drying of electrodes are necessary. So these two are the rounded welding defects. It can be exempted to some extent, but no linear welding defects is permitted in welding. Next, what is the question? How does the arc length and torch speed affect the welding? Yes, arc length should be 2 to 3 millimeter for any welding process, TIG, MIG, MMW. Torch speed, the speed should not be very high, should not be very low. The speed should be optimum. Next question. Okay, can you please explain that 2G topic again? 2G stands for horizontal butt joint. If the butt joint is welded in horizontal position, it's called 2G as per ASME, American Society of Mechanical Engineers. What is the effect of uncoated wire in case of CO2 welding? The effect will be the porosity. Don't use CO2 for MIG welding. Go for a argon CO2. The best is 82% argon and 18% CO2. The both will give you best results. In stainless steel welding, how can we reduce the bulging uneven surface? In stainless steel welding, if you go for a TIG process, you must use purging of the weld. That is, purging on the underside of the weld. Then you can get good welding for your stainless steel joint. Next, welding failure on a compactor, cold crack. See the pictorial view. This is for not having qualified welding procedure. No preheating in high thick joint. Use of excessive high amperage. Excessive heat input. Undermatched filler metal. Engage untrained welder for this job. No analysis of vibration. Typical failure Failure due to insufficient filling of weld metal before breaking the arc. This is an example for any process. If you go for MMW, TIG, MIG, this crater crack is occurred in every welding joint which is done by the untrained welder. This shows the reason that filling is not done, insufficient filling at the end of the weld. Undercut due to use of high current in MIG process. Check the undercut. This is for excessive high current and excessive welding speed. Next, failure due to insufficient current in MIG process. Check the high welding speed. For high welding speed, lack of root fusion, this portion. For high welding speed and low current, the welder has been used. This is lack of root penetration. Undercut due to use of high travel speed and high current. These are the butt joints. See the pictorial view of undercut. This is for high travel speed and high current. Failure in radiographic testing due to scattered porosity in MIG process. This is for lack of cleaning. The joint which is done by MMW root, then not cleaned properly, and the rest of the rounds to be done by the MIG process but not cleaned properly. So result is the porosity in MIG process. See the pictorial view. Excessive reinforcement. This is due to very low welding speed in MIG process. So excessive low welding speed will give you like this joint. Burn through defect due to high amperage and wire feed speed. If you use MIG process with excessive high current, then you can see this type of burn through or melt through in your butt joint, in the underside of the joint. Uneven bead defect due to fast weld travel speed. In MIG process, if you go with excessive high welding speed, you can see the results in the pictorial view. Uneven welding bead and lesser welding strength. This is called porosity by MIG process. This is due to lack of gas shielding in MIG process. The gas shield, it may be for low rate of gas flow, or it may be for lack of gas in the cylinder. So this is the porosity that should be avoided in MIG welding. This is a picture of cold crack in a chassis of backhoe loader due to lack of qualified welding procedure. This is also a structural failure and welding failure. Crack, this is due to lack of welding procedure, proper welding procedure, lack of proper welder. So this should be avoided. Transverse crack due to wrong welding procedure. Check in the pictorial view, transverse crack in the fillet joint. This is due to lack of welding procedure. Next questions. What temperature required? Oh, please speak in Hindi. What temperature required? Feet up gap of 2.5 millimeter is suitable for weld bead size. Yes, it is. It is suitable for MIG also. For MMW, you have to check the root gap, actual root gap in the joint. If it is 2.5 in your root gap, so you should use 2.5 diameter of electrode for getting good penetration and good fusion. What temperature required for proper fusion? For mild steel, the temperature required is above the melting point of the material. If the melting point of the material is for MMAW 1530 degrees centigrade, you have to go above the melting point. For copper's melting point is 1083 degrees centigrade, so you have to go above 1083 degrees centigrade for fusion welding. If the material is aluminium, the aluminium material melting point is 660 degrees centigrade, so you have to go above the 660 degrees centigrade for fusion welding process like TIG, MIG. But there should be a caution for aluminium welding. You have to remove the scale of the MIG, which is aluminium oxide, by any mechanical process or chemical process. Then you have to go for weld by TIG or MIG. Next. How distortion is calculated? It's a very practical question. Distortion can be controlled by the following: reduction of effective shrinkage forces, making the shrinkage forces itself to work to reduce distortion, and balancing one shrinkage force by another. These are the three to control the distortion. I can give you all the details if you send the questions in our website to Tata Steel or Versus Communication. Will be giving answer for your question. Some welding electrodes through more fire during welding as compared to other. No, this should be, there may be a spatters, more spatters in some electrodes. More spatter means weld metal loss. So you have to control those spatters by using, if you go for MIG, you can use shielding gas properly, or in MMAW process, more if there is any more spatters, so you have to go IGBT type of machine to reduce the spatters. How to redye the electrodes? You may redye the electrodes by using oven. It may be portable, it may be Welding type. For 6013 electrodes, the baking procedure should be 30 minutes maximum in 80 degrees centigrade. For 7018 electrode, low horizontal type, very important, you have to go for rebaking for 1 hour at 250 degrees centigrade before use. So that is very important for low horizontal type of electrodes. Yes, we are coming in MIG. Please explain MIG welding process also. Yes, we are coming in MIG. Welding parameters and mode of metal transfer too. Next, setting up welding parameters in GMAW. The weld bit geometry, depth of penetration, and overall weld quality depends on the welding parameter setting, which is also known as welding variables. Welding parameters in GMAW process depends on the following. Welding current is also related to the wear feed speed. Polarity, arc voltage, welding speed, length of stick out, electrode orientation, electrode diameter, shielding gas composition, and gas flow rate. These are very important parameters in MIG process. Welding current, arc force, and deposition rate being dependent on current. Operation above the transition current. Make the arc unstable. Please check your current. In MIG process, there is a transition current, transition range. Don't go above the transition range maximum excessively. Then your arc will be unstable in vertical and overhead position. By reducing the average current with pulsing The arc forces and diffusion rates can both be reduced, allowing welds to be made in all positions. With all the other variables held constant, an increase in welding current will result in the following: an increase in the depth and width of the weld penetration, an increase in the deposition rate, an increase in the size of the weld bead. Direct current state polarity, these are called polarity. Polarity may be of two types: DCSP or DCRP. DC state polarity or DC reverse polarity. DCSP also called DCEN, DC reverse polarity also called DCEP. That is why DCEP is almost always used in GMAW. The electrode melting rate is much higher in DCEN polarity, but the metal transfer mode is being globular. This polarity is seldom used. AC is not used in GMAW because of the tendency of the arc to extinguish as the current passes through the 0 point. So polarity is very important. Always use DCEP. Majority of the GMAW application use DCEP or DCRP. This should be used actually. This gives a stable arc, smooth metal transfer, good weld bead, less pattern, and high depth of penetration for a wide range of welding current. Whereas in case of DCEN or DCSP, only globular transfer is possible. Always avoid the globular transfer. The arc length, this is related to arc length. The arc length is a critical variable in GMAW. It must be carefully controlled. The arc length determines the current and arc pressure of the weld pool. When the length is too short, the electrode can contact or short circuit to the weld pole, which will result in a base metal melting, a high and narrow weld deposit. On the other hand, excessive arc length causes a wider shallow deposit, makes the arc to wander, increases pattern, may cause porosity from air entrapment. Arc length is an independent variable in MIG process. Length of stick out, this is related to the stick out. Length of stick out is the length of electrode extension from the contact tip to the tip of the weld. The length is called stick out or electrode extension. Higher length of stick out will offer higher electrical resistance, will cause a higher voltage drop. The higher resistance will also cause the resistance heating on the electrode, resulting in a small increase in the electrode melting rate. Length of stick out. What should be the stick out? What is the stick out? What should be the stick out? However, the increase in the length of stick out increases the overall resistance in the welding power circuit. Therefore, reduces the welding current. The power source generally used in GMAW system will be flat or CV type characteristics. As I said earlier, for MMAW, the power source should be CC type. For MIG process, it should be a CV type characteristics. The electrode feed rate is constant. With this constant potential system compensates for the variation of the length of stick out automatically, supplying the increased or decreased welding current. The stick out should be as follows. Like if you use short circuit arc or deep transfer, the stick out should be 8 to 12 millimeter. For globular transfer, the stick out should be 15 to 18 millimeter. For spray transfer, the base transfer in MIG welding, the stick out or electrode extension should be 15 to 22, 23 millimeter. So electrode orientation, the angle of the torch called electrode orientation. The electrode orientation with respect to the weld joint affects the weld bead shape as well as weld penetration. Very important. For good quality welding, the main point is good penetration. The influence of the electrode orientation on weld bead shape and its penetration is more than that of the arc voltage or welding speed. The electrode orientation is defined in two ways. The relationship of the electrode axis with respect to the discretion with direction of the weld travel is known as the travel angle or electrode orientation. The angle between the electrode axis and the adjacent work surface is called work angle. When the electrode points against the direction of the travel, the technique is called backhand welding technique with a drag angle. When the electrode points in the direction of the travel, it is called forehand angle with a lead angle. The primary function of gas shielding, composition of gas shielding. Any question, please?
Yes.
What should be CO2 pressure in MIG welding? I refer, you should avoid CO2. You should use argon CO2. 80-20%, 80% argon, 20% CO2, or 82% argon, 18% CO2. Best is 80-18. What should be the CO2 pressure in MIG welding? The rate of gas flow in CO2 should be around 15 liter per minute if you work within the workshop area. If you use the CO2 in the exposed area, you should go for 17 liter per minute, but CO2 will not give you good quality weldment except there is no penetration in CO2 and the penetration depth will be more. That is two advantage by CO2. But if you go for argon CO2, you will get very good quality weldment for your job. Next. What is ISE? No, there is a there is an abbreviation, International Institute of Classification Societies. International Institute of Classification Societies, but no ISE. Method to calculate the gas flow in MIG welding. Yes, liter per minute. If you use the gas flow within the factory, within the workshop, you should use a flow meter. A flow meter, the capacity should be capacity of the flow meter should be 25 liter per minute. You have to go 13, 14 to 15 liter per minute for your shielding gases. Does gas volume differs for different thicknesses? If yes, what could be the liter per minute of flow? Yes, gas flow should be increased if the welding current is increased. If the plate thickness is low, your gas flow rate should be low. If the plate thickness is high, your gas flow rate should be higher. Because if you weld in the high thickness, your current should be more. The more current you have to use, the more gas flow will be required. Next question, how to control bulging of stainless steel welding? What is the process you are using? Please tell me. What is the process? TIG, MIG or MMAW? What is the process? How to avoid spatter problem in projection bar welding. That is, are you using electric resistance welding? So there is no spatter. Do you use MIG welding process? Then spatter can be reduced by using argon CO2 80 to 18%. Then it can be reduced if you set the parameters properly. Welding parameter setting is very, very important. Next one. Shielding gas composition. In addition to this, the shielding gas performs a number of important functions. Forms the arc plasma. Stabilizes the arc root on the material surface. Ensures the smooth transfer of the molten metal droplets from the wear of the weld pole. Shielding gas composition. Thus, the shielding gas composition and its flow rate have a substantial effect on the following. Arc characteristics, very important. Mode of metal transfer in MIG process, very important. Penetration and weld bead shape is also important. Welding speed for getting good production is also important. Undercutting tendency is also important. Cleaning action, weld metal mechanical properties, all are very important in selecting shielding gas composition. Shielding gas composition, the principal gases used in GMAW process. Principal gases. CO2, it can be used in steel. Argon CO2, it can be used in steel. Argon 80%, CO2 20%. If you want more quality weld, then use argon 82%, CO2 18%. Argon CO2O2, it can be available 98 and 2%. 90% argon, 8% CO2, 2% O2. It can be used for steel also for getting good quality product. Argon plus O2, 98 2% or 99 1% can be used for stainless steel in MIG process. Argon or helium or argon-helium mixture should be used for non-ferrous material in MIG process. Gas flow rate, check the gas flow rate should be around for argon in MIG process or argon-based mixture should be around 15 liter per minute. But if you go for helium, it should be double, because the density of the helium is less in comparison to argon. So, if you go by argon, around 15 liter per minute should be used, but for helium, it should be minimum double because of the less density of the helium gas. CO2, avoid CO2. I repeat, avoid CO2. If you go by CO2 gas, it should be 15 to 17 liter per minute within the workshop. But if you go in the exposed area for welding by MIG process by using CO2 shielding gas, should be the rate of gas flow should be more. But I refer use argon CO2 by MIG process for mild steel, for carbon steel. So these are the rate of gas flow. Welding of galvanized steel. Somebody was asking for welding galvanized steel. Done almost exactly the same way as welding of the bare steel of the same composition. The same welding processes. MMAW, MIG. These can be used. Bolts, amps, travel speed, etc. can be used with little modification within the switch is made from uncoated steel to galvanized steel, unless the zinc coating is usually thick. So, if you go for galvanized steel welding. The difference between the welding galvanized steel and the welding uncoated steel is a result of the low vaporization temperature at the zinc coating. Zinc melts at about 900 degree Fahrenheit and vaporizes at about 1650 degree Fahrenheit. Since steel melts at about 2750 degree Fahrenheit and the welding arc temperature is 15,000 to 20,000 degree Fahrenheit, the zinc that is near to the weld does not stand a chance. It's vaporized. The vaporized zinc increases the volume of the welding smoke and fumes. The zinc at the near any weld is actually burnt off by the heat of the arc, removing the protective zinc coating. Grind off if you require, if your welder is skillful, if your welder is knowledgeable, grind off the zinc at the interface of the weld, wherever you have to weld, and wear a suitable breathing mask, because mind that galvanized fumes are lethal. The welding engineer should also check the welding electrodes which are being used for this galvanized steel for high silicon levels. Excessive silicon can cause zinc to penetrate the weld metal, leading to cracking, especially when the zinc coating is thick. The silicon in the welding electrodes should not use 0.85%. This means that the commonly used ER70S6 pillar wire for meat should not be used when welding galvanized steel. Best welding practices for galvanized steel: manual metal arc welding. You can go for E6011, you can go for E6012, you can go also E7016 by using MMW for welding galvanized steel. For me, you can go gas metal arc welding E70S3. Do not use E70S6. You have to use E70S3. And the best results for galvanized steel welding will be given by ER71T14. You can weld all your joint by using flux core arc welding process as well as flux core wire E71T14. Next question, please.
I call Rahul.
Yes. Attending the question, please. Best welding practice for stainless steel welding. If first you have to check the welding position for your stainless steel welding. If you have pipe welding process, use TIG. TIG welding process is the best. Or if you have plate welding for stainless steel, go for MIG and TIG both. Or you may use also MMW process. No problem. But in pipe or out of position welding, TIG process is the best process for stainless steel. Next. What is the ideal length of stick out? Ideal length of stick out for mode of metal transfer. If the short circuiting mode of metal transfer, if you are in use for deep transfer or short circuit transfer, the stick out should be 8 to 12 millimeter. For globular transfer, 15 to 18 millimeter. For spray transfer, 18 to 22 millimeter. Next question. 0.8 or 1.2 dia electrodes. No, these are using in MIG process. In MMW, the electrode diameter should be 2 millimeter, 2.5 millimeter, 3.15 millimeter, 4 millimeter, 5 millimeter or 6.2 millimeter. Or for special cases, if you give special order, 8 millimeter dia can also be available for MMW process. Next question. What should be the weld time for MIG welding and spot welding? Spot welding is done by ERW process. This is not taken into our this program. For MIG, MIG is the best process for welding speed and production. If you want higher productivity, go for MIG. So there is no alternative for MIG in manual welding process. Or if you have a chance, you can use submerged arc welding but there is a restriction for submerged arc. You have to use it in flat position only, not out of position. Next. Intelligent arc control. Yes, intelligent arc control. The welder should be trained how to control the arc. What is the ideal arc length? Who has to perform in your job? The ideal arc length is 2 to 3 millimeters. What is the benefit of 80-20 ratio argon CO2 gas in MIG process? The benefit is by using this gas is higher mechanical properties, which is prime concern in a bar joint. High mechanical properties, highly good bead appearance, very good weld profile, very good penetration. All we can get by using 80-20 or 80-18 argon CO2 gases. Yes, we are going through by MIG welding. SS welding using MIG welding best practices. Yes, if the welding process, if you do it in your workshop, you can go for MIG. For MIG process, select the proper shielding gas for your application. The shielding gas should be for stainless steel 99% argon, 1% O2 or 98% argon, 2% O2 for stainless steel butt joint by MIG process. What is the use of argon gas of added in CO2 welding? Argon gas give you high mechanical properties. That is the specialty of the argon. Argon give you very good weld profile, which is required in your application. So, base process by the MIG is argon CO2 shielding gas, not CO2. Next. GMAC. No, is there any particular reason that why argon is mixed? Yes. Yes. For getting spray transfer in MIG welding process, I'll be coming. In MIG welding process, there is 3 mode of metal transfer. One is called deep transfer, one is called globular transfer, and the other is called spray transfer. You can get spray transfer by using argon CO2 only. You cannot get spray transfer, which can be given. The CO2 cannot give you base welding by MIG process. If you go argon CO2, then you can get the spray transfer as well as high mechanical properties, higher bead appearance, very good weld profile by using argon CO2. Gas metal arc welding, also known as metal inert gas welding, MIG process, or metal active gas welding, where you use CO2 gas. What is GMAW? GMAW is also called MIG-MAG. So, should be used in DCRP polarity. Check the process, arc length, solid electrode wear, shielding gas, wear guide. See, contact tip. In the pictorial view, contact tip is the wear guide which are using in MIG process. Metal transfer in GMAW, very important. Metal transfer in GMAW process depends on the following: magnitude of the welding current, current density, shielding gauge, and stick out. As I have seen in the earlier slide, the stick out is called from the end of the contact tip to the tip of the wire is called stick out. Mode of metal transfer in GMAW. See, short circuit transfer or deep transfer is also called deep transfer. Then globular transfer. Then spray transfer. The best transfer in MIG process can be available by using spray transfer. Spray transfer. Don't go for globular transfer. And pulse spray transfer. These can be available only in the special type of machine. Mode of metal transfer in GMAW. Check short circuit transfer or deep transfer. Globular transfer, spray transfer. These three transfer can be available in any MIG process. But pulse transfer is only available in pulse type power sources. And the best transfer is spray transfer. So always check the pictorial view. When you increase the current and voltage from short circuit to globular, transfer will be available. Then if you again increase the current and voltage, you can get the spray transfer. So see the pictorial view in mode of metal transfer, short circuiting transfer, globular transfer, and spray transfer. And spray transfer is the base transfer in MIG process if you use argon CO2 shielding gas.
Can we just fast because we're using.
So short circuiting is like this. Mode of metal transfer in GMAW. The method of transfer used has a significant effect of the welding speed and quality and therefore economies of the process. See, the effects of the amperage in MIG process use 100 amps, bad quality weld, use 150 amps, slightly improved, but best use in 200 amps because spray transfer will start from this. So you can get high quality weld by using spray transfer. Question please. What should be the minimum penetration for good strength in MIG welding? Okay, as per ASME section 9, QW403.3 say international code, ASME section 9, QW403.3 is it should be minimum 5% of the thickness of the material, minimum, maximum 10%. There may be some addition, alteration. There is a direction for this. You can check in ASME section 9 QW 403.3. Next. Okay. Which Indian standard can be referred for penetration, mechanical strength for 1/8 sheet MIG welding? Indian standard is BIS, IS 7310, IS 7308. For mechanical strength, you can get it IS 7310. But go for ASME section 9 or ISO 9606. That is better. In MIG welding, no, there is no question actually. In MIG, MG welding. MIG welding, yes. How to reduce the bulging gas in SS 1 millimeter sheet during MIG welding process. Yes, bulging gash. So there should be for 1 millimeter you have to use pulse machine for 1 millimeter thick. But it is better to use TIG welding process and with back purging on the underside of the weld. You'll get very good quality welding. What to do to reduce the spatters in MIG welding? Use argon CO2 80 to 18% and set the welding parameters properly. Then the spatter may be almost zero. Otherwise, you can call me. Want to know other welding parameters for cold rolled steel? Yes, you can go for MIG process or MMAW for cold rolled steel like cotton steel produced by Tata, isn't it? So cotton steel can be welded. Cotton steel can be used for cold roll or hot roll, can be used by MIG process. Next question. If CO2 used in robotic, what will be the effect? Don't use CO2 in robotics. For robotics, you have to use argon CO2. Use 80 to 18 for robotics. I have used, giving you good result. For 1.8 ms sheet, MIG welding, we are using current 220 amps, voltage 2025, gas argon EQ. No, not possible. For 1.8 mm thickness, ms sheet, you cannot use 220 amps. You have to go for a deep transfer for using for 1.8, 60, 70 amps with 16, 17 voltage. Please tell me a proper welding position for MIG welding. MIG welding can be done in all positions: flat, horizontal, vertical, overhead. In any position, MIG welding can be done. No problem. Next. Okay. What is the cold metal transfer welding? Cold metal transfer is available in MIG process. So cold underside weld, underwater weld. So metal transfer is available only by MIG process. Next. Check the transfer of weld metal transfer by MIG process. First is deep transfer or short circuiting transfer. Low current and low voltage should be used for deep transfer. This is used for sheet metal and out of position welding like vertical, etc. Check the pictorial view for short circuiting. The pictorial view, gas nozzle, electrode, inside is contact tube. So these are using in short circuiting or deep transfer. This is done by short circuiting deep transfer in a pipe welding joint. Deep transfer acid and low current and low voltage has a short circuiting arc, low spatter with control heat input suitable for thin sheet and out of position welding, that is vertical welding. Check the globular transfer. Always avoid this transfer. For big process, go for deep transfer or spray transfer wherever possible. Don't go globular transfer. Avoid globular transfer. For the quality of welding, you do not get quality weld by using globular transfer. So These are the globular transfer. In globular transfer, your 8 to 10% weld meter will be lost. So, globular transfer, erratic arc. This is a pictorial view of globular transfer. Erratic arc, never get good quality weldment by using globular transfer. Globular transfer and intermediate stage between deep transfer and spray transfer. Droplet sizes are more than the diameter of the electrode, produces excessive spatter and erratic arc behavior. Will not get good quality. Spray transfer, like a spray of water, will give you best results. Higher current and voltage can give you spray transfer. The best transfer in milk process. Droplet sizes, same or lower than the word diameter. Your word diameter is 1.2 or 0.8. The droplet sizes, if the droplet sizes is lower, then your quality of weld will be finer. Higher deposition rate will be available. Penetration will be very good. Fluidity of molten pool increases the productivity by using spray transfer. So, globular transfer CO2 welding will be giving very bad quality weld. So, spray transfer achieved only with the argon based mixture at higher current and voltage. Spray transfer, true spray transfer will not be available by using CO2, only available by using argon CO2. Very smooth arc and minimal spatter. I can give you the technique. It can give you only zero spatter also. For MIG welding, by CO2 gases, by using CO2 gases, your weld metal loss will be 8 to 10%. But the spray transfer, if you use for argon CO2, your spatter loss will be almost zero. Achieved a flat and shiny bead by using spray transfer. So this is a pictorial view of spray transfer. Check the quality of the weld visually. So spray transfer give you this type, this weld profile will give you exceptionally good result. But by using globular transfer, your joint will be, the joint strength will be reduced, the bead appearance will be very bad, good penetration will not be available. So always go by two transfer, deep transfer, either deep transfer or spray transfer. Don't use globular transfer. So if you use pulse transfer, so this is the pictorial view of pulse transfer. Always use 5 pulse. See, the profile of the weld is the best in 5 pulse if you use pulse type power sources. So these are the pulses, pulse setting, high pulse current, in pulse, maximum current, peak current, medium current, base current. Always, if you have a pulse machine, there will be a very good quality weldment for pulse using pulse type power sources. Pulse transfer, control method of transfer mode, give extremely precise control of weld metal transfer penetration to give you superior quality weld. Heat input of to the job is controlled by the low background current with high pulses using special type of equipment. So pulse is, high pulse is the best pulse. This is the pulse mode, MIG welding. So pulse setting, this is a welding which is available in pulse type power sources in MIG process. Check the welding, see the welding, unique type of welding is available by using MIG process. Check the spray transfer by using pulse and other type of power sources. Extremely high in pulse. This is a pulse transfer setting. This is a forehand technique using in MIG process. This is push technique or forehand technique. Can give you flatter weld. This is a backhand technique in MIG process. This is called pull technique. This can give you only high penetration. Otherwise, you have to go forehand technique in MIG process. This effect of the CO2 and argon gas, very important. Thank you. If you have any question, please send it to us. We'll give you answer. Next question. What is the cold metal transfer welding? Cold metal transfer. This is also a weld metal transfer by MIG process. Next. Blowholes in ZS heat during CO2 MIG weld. What is the remedy? Use argon CO2 80-20 or 80-18 to control the porosity of blowholes. What test we should do for quality verification of resistance in welding on 0.5 mm? No, ERW is not our topic today. We can give you next. So my suggestion to all of you, all the attendees, train up your workforce in welding process. Whatever the process you use, manual metal arc welding, TIG welding, MIG welding. If you want to get quality job or market share in India, you can get it through the upliftment of the welder by giving training. Training is not an training is an investment. It's not expenses. So train your workforce and you can get good quality. Thank you. Thank you to all of you for attending this webinar.
Thank you so much, sir, for sharing your knowledge. Thanks to all the participants for joining this webinar. This is the second time we have organized this webinar. Special thanks to those persons who have asked questions actually, because more it is interactive, more we can add value in these kind of sessions. We know this the welding is a very huge topic and we have only 1.5 hours. So Mr. Apurba Sanyal has tried his best to conduct these sessions. In future, maybe in this month, in the next month, we are planning similar kind of sessions. Request all of you to join and please communicate to other persons or other team members in your company or even in the fellow companies also to join our sessions and give us the feedback. After this session, we are going to send one feedback mailer. Please give actual feedback so that we can improve our activity, or we can say this kind of webinars. Thank you so much.
More questions.
And one more thing is just we want to mention, for more questions, request you to please mail us in eCafes connect @ecafes.com. Also, you can visit our website ecafes.com. There is one thing called Ask. There also you can put your questions. Thank you so much.
Why don't you unmute it?